So we'll introduce to you Ink smart contract on Polkadot. So first I will present to you what is the Astar Wasm stack for smart contract. So first thing, our layer one, of course, it's a substrate, it's a parachain, it's connected to Polkadot and Kusama. Our engine, so our smart contract engine, is palette contract that use Wasm because here you need an interpreter to interpret your Wasm code. The language used to write smart contracts, so what you will use is Ink, and it's written in Rust. You also have a set and standard called PSPs, so Polkadot standard proposal. You have PSP 22, 34, and 37 that is mapped to their ERC equivalent. So here it's a image by Ink, by Parity. To explain a bit all the layers. So on top you have Ink. You can also compile a Solidity using Solang compiler to Wasm and then deploy it to palette contract. And you can also use ask, that is assembly script. So if you don't know Rust, you can also use this one. Please note that at the moment, if you plan to deploy your contract in production, Ink is fully audited by OpenZeppelin, so it is definitely the to-go way if you want to go for production. Solidity with Solang compiler works, but some stuff is not working. They are actually working on it at Parity to make it production ready as well. And ask, it's pretty much experimental. It works, but something cannot be implemented, and it's not really up to date. So it's only like used as a learning tool, but it's not audited, so it's not it does not target live environments. Then there is 3 dots, meaning that a lot of language can be compiled to Wasm. So in the future, we can see many new EDSL that will target as palette contracts. For example, a C# one or a C++ one, or a new assembly script EDSL. And then you deploy your Wasm into the blockchain. And this Wasm, we through the API of palette contracts, you can see set storage, get storage, color, random, terminal transfer. This is host function of palette contract will actually interact with the blockchain. Important decision. So why Wasm? So palette contract is a pretty new environment, meaning that the development started like 4 years ago, 3.5 years ago. So after EVM, after Cosmosm and so on. So they had a lot of time thinking of the design decision. And when you choose an instruction format, it needs to have a lot of specificity that need to meet your requirement. And WebAssembly, Wasm, basically meet all those requirements. So what are those requirements? First thing, wide language support, especially for Rust. So Rust is definitely the best language to write blockchain now because it's memory safe by default. I mean, at compilation time and not at runtime. Also, Wasm is really performant because it first intended to be run on host machine web browser. So of course they had to create a compiled language that is really fast. It's memory safe and executed in his own environment. So there is no memory leak possible. It's also deterministic, which is really important. It works well with Wasm interpreter. That is an interpreter that has a high degree of correctness. because smart contracts are untrusted code compared to, for example, pallet code that is trusted code because it's basically the developer of the blockchain that deploys it, while a smart contract is basically anybody. So that's why they use Wasm. And also it produces a small size binary. So when you compile your contract, it will be a small size compared to other instruction format. And this makes a big difference because on chain, there's two really scarce resources. It's execution time and on-chain storage. So a lot of people asking, so but what's the real difference between Wasm and EVM? So last year, Pendulum created a small like a test, and they benchmarked EVM using Get, so the basically the Ethereum implementation, the most fast one and most used. Also EVM palette on Substrate. Contracts palette solidity compiled to Wasm using Soleng on contracts palette. Then ink deploy on contracts palette, and what format, which is basically it's not ink, it's directly Wasm. It's Wasm text format compiled to Wasm, but it does not intend to really build a dApp. This is really for research purpose. So you can see, so they had like two different tests. So one with hashing, the other with odd number. But this is just to have like some benchmark that ink can do that is way more performant than Solidity, and especially compared to, of course, Solidity in EVM. And they said that they measured a performance difference between both technology up to a factor of 23. And this was May 3 last year. So right now, I think the gap is even bigger. So Ink. So Ink is a language to write smart contract in Rust. It has been audited by OpenZeppelin beginning of the year. And this is a quotation they have made in conclusion of their audit, that Ink demonstrated a robust security and safety and security for its user. And you can really see that right now, OpenZeppelin is really making, really going toward helping Ink and providing Ink audits. So they really like the technology, and I think they really support it. So Ink feel like Rust. On the left, you have like a flipper, a basic struct with some function associated. And you can feel on the right, this is a same struct with Ink, with attribute macro, one for the storage, one for the mode on top, and a constructor and message. So Ink is a programmable layer of Substrate, because in Substrate you have palette, but basically it's only made by the blockchain development team. But as users, they cannot deploy a smart contract. So Ink use Rust smart contracts, so it shares the same language as its layer on what it's deployed on, which is palette contract and Substrate. So you have the same language across basically the environment and the smart contracts, which allow to share the same generic type with the runtime, which is account ID, balance, and so on. So it's really easy to interact with palette. So we have chain extension, we have call runtime to actually enable contracts to call other palette, XCM, XVM, and assets are coming. So what are the tools to develop on Ink? So first thing is a Swanky Suite. So we will use it. It's a all-in-one tool for Wasm smart contract.
Pierre, sorry, you
Yes.
are off the spotlight. You have to like walk back. Your avatar is off the spotlight.
Okay.
Yeah, sorry. Yep. Okay, yep.
Sorry, I press right on the not on the grid screen. So yeah, Swanky is only one tool to develop a smart contract, and we will use it. So I can present it to you. We have also Chain ID. So it's still under development, but when it will be live, we will be able to show it. But it's basically a tool to develop Ink smart contract and to deploy them using your browser. We have also Brush Farm that is basically the Open Zeppelin of Ink smart contracts. So OpenBrush is Open Zeppelin, it has all the standard implementation and so on. Sol to Ink that can directly transpile your Solidity code to Ink, and also TypeChain that will generate a TypeScript type out of your Ink smart contract. So it will be really easier to implement it for your UI and front-end development. So your developer journey. First, it will start by learning Ink and learning Rust. So you need to set up your environment. So Rust, Cargo Contract, and Swanky CLI. The documentation that you can go through is Astar Docs first under build Wasm smart contract. To go more into Ink, you can check use.ink website and then also OpenBrush docs if you plan to use OpenBrush. We have a set of tutorial in Astar. It's available in our doc under Wasm tutorials. We have 3 tutorial, one first entry-level Flipper, then an intermediate NFT, and then an advanced Uniswap v2 where we will implement basically a pool and factory of Uniswap v2. So please go through this tutorial if you want to learn. Then you will start developing your contract on local environment. So for this, you will use Swanky. That will quickly spin up a local environment where you can build, test, deploy. Actually, you can deploy on local, but also on live environment, test environment. You also have Swanky node, and you can manage your network account. You can add account for local, but also production account that will be encrypted with passwords. For testing, you have 2 types of tests. So Ink end-to-end tests written in Rust. You can check Ink example repos. There's a lot of them. And also a TypeChain Polkadot that is that will use basically it's a TypeScript test that will use Chai or Mocha to be run. But then TypeChain Polkadot will actually generate your types, so it will be really easy to use. And there's a lot of example in their repo or in Swanky dApps showcase. For UI, you have Polkadot.js, of course, you will have to use it, Astar.js, and also they created a new product, which is really nice. It's Use Ink, which is a React hook library for Ink. It's really, really handy, and it really save a lot of boilerplate code. And right now, we can say that write a dApp front-end UI for Ink is finally really simple. We have some template if you want to check already existing dApps. So in Swanky dApps, templates or one lottery, you can check NFT and also NFT marketplace. We mark Ink. So the network, in blue you have the Astar network, and in pink you have the Polkadot parity network. As a testnet, we have a Shibuya, and as mainnets, we have Shiden in Kusama and Astar in Polkadot. And of course, all of this parachain support Wasm smart contract, so you can deploy on Shibuya, Shiden, or Astar. We also have dApp staking. That is a decentralized way for developer to earn some rewards and to incentivize a mechanism for innovators. So please check it out and start staking. And if you have a dApp project, please register to get dApp staking. There's also an incubator with 3 different tracks. So for builder, for tools, and for audit. So please check the website. Just type incubator in Google and you will find it. It's funded by Polkadot Treasury and led by Sota. And if you start building, this is really the next step for anyone to start building. So happy hacking, and let's start. I will write a small ERC20 using Swanky, and I will explain. Let's start. So now I just, if you have done this, your code space should be ready. And here you can start, you can basically type any Swanky command because, of course, all development environment and Swanky is installed in this dev container. So first command is to init a new project. So Swanky init, we will call it ERC20. Of course, it's a bit slower because it's hosted. You can also, of course, install Swanky using npm package on your machine, of course. So we will choose blank. What should be the name of our initial contract? ERC20. Our name is Pierre-San. Email, we don't care. Do you want to download Swanky node? I will say no because I will run it on my local machine and then deploy it. So it's installing. Okay. So now let's go into this ERC20 folder. And then let's start writing our contract. So here we have ERC20. We have Inc version 4. So let's update it to further 2. And scale it for 2.5. And everything else is good. Now in the lib, so what we will do is create a ERC20 and just implement a transfer, because implement everything will take too much time. So first we need to create our storage. So what will the storage contain? Of course, it will contain total supply of the ERC20 and also the balance mapping to know which account has which amount. So for this, you need to create, I will explain. It's basically a struct with Pascal case, because this is a Rust convention. It has attribute macro inc storage to say that this will be the storage of the contract. Okay. And it will derive default if you have a mapping. So total supply is a balance. Balance is basically a U128. and we have balance, which is a mapping. Here, this mapping, we need to import it like this. Okay, so we have our storage, and now we can implement this, have an ample block for the storage. So let's implement it. And then we need a constructor. A constructor, you can have several constructor of arbitrary name as long as they have this attribute macro on top. So here we will have, of course, every public that are callable from the outside should be public. So it's new, and of course we need to specify the total supply. Okay, that is type balance, and it should all time return self with capital self, because here we are, there is no instance of ERC20 because this constructor will create the instance. So this refer to the type and not to the instance of the struct. Okay. So when you have a mapping, you should initialize it with default. Okay. Then, of course, you have specified total supply, but then we need to transfer mint certain amount to the color of this total supply. So to get the color, it's basically self and color. And then you will get the color address, and then you will insert into the balance mapping the color as account ID and the total supply as balance. And then here we emit an event, transfer event from nobody, because when you mint is basically from a node, and to color, and the value is total supply. Now let's add this event. So let's add it on top, and here this is how event are made in Ink. So it's also a struct with some fields, and it will have Ink event attribute macro, and you can have topics which will be help indexers, maximum 4 topic per event. And here it takes option, because when you mint, this will be known, and when you burn, 2 will be known. And then, of course, you should return the instance of ERC20. Now let's have, for example, a getter. So right now we have by default in Ink there is no getters, so you should add getters. So here this is a getter for balance off. You pass an account ID, which is the owner, and then if it found nothing, then it returns 0. Okay. So right now, let's check if our contract is already building. So Swanky contract, compile ERC20, and then we'll put variable. So if there is an error, it will display it. It will take some time. It's hosted environment.
Hi, Pierre. While the thing is loading, we have a couple of questions from the participants.
Okay.
So one participant asks, is there a reverse to Soul 2 Inc?
Is there what?
A reverse to Soul 2 Inc. Let me type it in the chat.
So from ink to Solidity?
Yes, correct.
No, there is no such things. This is only from Solidity to ink.
Okay.
I wonder who wants to use that.
Thanks for answering the question. And we have one more question. So another participant asked, if we get any questions or doubts during ink development, which is the best place to have it resolved as soon as possible?
So the first thing is, of course, after checking the doc, is to ask on Stack Exchange. If it's not like an ink question or Rust question, and then it's like, for example, about deployment or Swanky, for example, you can also use Stack Exchange and use tag with Swanky or Astar, and we will answer there. And we also have a Discord. I think I see that Codspool already have shared it, so you can also ask at there.
Thank you. Thank you for answering the questions. Yeah, so if it's loaded, you can continue your session.
Thanks, Zail. So it's building fine. So you can see that here in artifacts we have our ERC20 contract, so we can already deploy it. But let's continue. We should also add a getter to get the total supply. So here it will just return total supply. There is no unwrap because the type is balanced.
Sorry, Pierre, is it possible to zoom
Uh,
in? Because I think the text is a bit small.
yeah, here we go. How to zoom in? Okay, I
Yeah,
think it's
perfect.
better.
Thank you. Thank you.
Okay. And now let's add transfer function. So what function that are callable for them outside should take ink message. Okay. Then of course they should be public. And here you can see that here it takes a reference of self because it will be read-only. But here in transfer will basically update the field of the storage. Okay, so this is really, I'd say this is really idiomatic Rust. This is how you do it in Rust as well. And here you take a mutable reference. Okay, so you can basically mutate self, and you can apply state change to your storage. Okay, if here you don't put, you just allow reference of self, then nothing will never be updated. Then the first arg, of course, when you transfer is to who, so to is an account ID, and the amount or value you want to transfer. Here it returns a result of nothing because by design, a state transition function does not return anything. When you there's two things you can do when interacting with the contract is either a dry run, so a query. So for example, when you will query this, it will get the total supply. Okay. And a transaction, and transaction return nothing by default. So here, no need to put something here because basically transaction only, it's only like successful and it return nothing. Or if it's a negative, error, it actually returns an error. So here, this error, we will add enum for, sorry, we'll add what do I do wrong? Okay, I see. We'll add an enum that will handle, like, the field of the enum will be the error of the contract. Okay. And this is the enum error. It has two variants: a sufficient balance. Okay, so we will check if the color has enough balance to actually be sent, and a sufficient allowance. But here we'll not implement allowance, so we don't need it. Also, it should derive, of course, debug partial PQ and EQ because, and also scale encode decode because it's used within it's returned. So every type that is used as argument or returned should implement encode and decode. And also for type metadata type generation, you should also have a conditional attribute that when it's built in stdmon, this is when you basically build your contract to generate metadata, but it's done automatically by a cargo contract. You should also derive type info. This is not this is not, you don't need to know all those details to start building, but at least if you know why. But this is like really details. Okay, so let's implement transfer. I hope that my brackets are not right. Okay. So first thing we need to know who is the caller of this message. So here we use, of course, small self because we use an instance of the struct, and then caller. Basically here we use env is basically the ink API. So ink env API, and there is a lot of functions. You can check it on on ink. So you can check the color, you can check the balance of the contract, you can transfer, you can know like what is the gas that is remaining and so on. So there's a lot of API functions. So please have a look. Then we need to know the from balance, and here okay, and here we will use self dot balance of impulse. So we'll implement this function, and it takes a reference of account ID because it's first, it's more performant in Wasm, and second, also if we don't do that, as we will use it after, we'll have to clone it, and cloning is really, it's not cost efficient in terms of execution. So you will use more gas. So let's implement this function, and this function don't need ink message because it will not be exposed to the outside. Then we need to check, of course, if the caller has enough balance, and if it does not have enough balance, we return an error of type insufficient balance. Then when it's done, we update. So the rule is all time check first and save after. So we have done the check. Now we can save it in storage and insert, basically decrease the balance of the color. And we will increase the balance of 2. So first we get the balance of 2, and then we add the value to it. So 2 balance plus value. Then we emit a transfer event. So from and to, and the value, and then we return OK. Then we can build, compile. Okay, so now let's try if it actually works. So here I will download the contract, okay, and I will run a local instance of Swanky node. Okay, so here I have my instance of Swanky node, and I will go to contracts UI. So contract UI.substrate.io add account, okay. And here I will upload a new contract code. And here I have my ERC20 contract that I just download from Swanky dev container. So you can see I have a new as a constructor, and I have only 3 messages: balance of, total supply, and transfer. So next. So here total supply, I will leave at least 10,000. And then let's deploy it. Okay. So here, of course, it was a field balance. So basically, the UI, when it's a field balance, it will read the chain decimal, and when you put actually 1, it will be 1 times the chain decimal. So here, 10,000 plus 15, 18 decimal of Swanky node. Okay, so what's the balance of Bob? So balance of Bob is 0, and balance of Alice is 10,000. So let's call transfer. So we'll call transfer from Alice, which is a caller here, to Mr. Bob, and value will transfer 100. Okay. So let's call it. Call was done, and now let's check the balance of. Let's check the balance of Bob, and he has 1,000, and Alice only had 9. Okay. So that's all from now. And if you want to go more, you can go to Astar Docs. Sorry, Astar Docs, and go to Wasm smart contract and read all the docs. This is really Astar focused. And yeah, here you have all the tutorials. So please go through the tutorials. Thanks for listening, guys. I don't know if there is any question. Because I cannot see the chat. Can we get the presentation? Yes. I cannot share the link, but I will share the link on the Discord, guys. Okay. Thank you, guys. Bye. Oh, Zale. Okay.
All right.
Hey,
Thank you, Pierre, for the very, very helpful session. Yeah, as mentioned by Pierre, he will share the link across on the hackathon Discord. So just keep a lookout if you want the slide deck that he was sharing earlier. We have also dropped the links that Pierre was sharing earlier in the chat. So all you need to do is just scroll up and you can find all the different links. And any last minute questions from any of the participants before we end this session? No? No? Okay, great. Yeah,
okay.
thank
Thanks,
you very
guys. See
much
you.
again. Yep. And thanks everyone for joining us tonight. And we'll see you guys next week for another round of workshops.
Bye.
Bye.